Hello and welcome back again. We're going to take a look at our Jacobians, but now we're going to take a look at a full example. Yesterday, if you remember, we talked about how to convert the bases. Today, our lesson is how can we rewrite our original as a new integral using our Jacobian substitution, our substitution technique. So we want to evaluate the volume under this function, f of x equals y. And this is bounded by the following ellipse, x squared plus y squared over 36 equals 1, and is transformed by the following, x equals u over 2, y equals 3 over v. So there's a couple things we have to do here. One, I want to use my Jacobian, so my rule for my substitution says we're going to take our integral, f of x, y, dA, and we want to transform that into a new one. Our new base is going to be, we'll call that s. That's our transformed base. F of u and v, so our function has to be in terms of u and v, and then we're going to multiply that by our Jacobian, and we'll call that jf. I guess don't need the magnitude on that one. And dA, remember the area of our new base. So, and remember, this just comes from this little formula right up here. We don't normally write that. We can write a little jf. That's our Jacobian of our function. So the first thing we're going to have to do is we're going to have to convert the base. So let's talk about the base right here. My original base I can get looking at my new region. I don't need to look at what the original looked like, but I want to get the new region. Well, to get that, I can just plug in my transformations. So I can plug this in. This becomes u over 2 squared plus 3v squared over 36 equals 1. Which, of course, this becomes u squared over 4 plus this becomes v squared over 4, which is 1, or u squared plus v squared, which equals 4. Now remember, this is a circle right here. A lot easier to integrate than an ellipse. So if I look at my circle, remember from yesterday, the other video, previous video, we're going to x, whoops, hello, that was interesting. Okay, I'll just undo that. There we go. We're going to let the x-axis be u and this axis be v. And I can write this equation of our circle. I can get my domain, my limits for this. Again, I'm going to draw a vertical rectangle. Well, my vertical rectangle is dealing with my change in v. Well, v goes from the bottom, which is the bottom of the circle, the negative square root of 4 minus u squared, and to the top, 4 minus u squared, the square root of that. And u, remember, this is a circle, radius 2, negative 2 to 2. It goes from negative 2 to 2. Now, so we've changed the domain now. There's my s. This is s. This is our new domain. That's our new limit. That's s. Now we have to change the function. So I'm going to change that. Now that's pretty easy to change. Change f of x, y. Well, what are they telling me? Well, f of x, y, they tell me, is y. Well, what is y equal to? We know y is equal to 3v. So therefore, my new function in terms of u and v is just 3v. Now I need my Jacobian right here. Well, to get my Jacobian, you might remember yesterday, this is just the partials. Hopefully remember, this is the partial of x with respect to u, the partial of x with respect to y, the partial of y with respect to u. Whoop, this should be not a y but a v. There we go. And let me see here. And the partial of y with respect to v. So let's go ahead and find these out. So the partial of x with respect to u is 1/2. The partial of x with respect to v, there is no v, so it's just 0. The partial of y with respect to u is 0, because there's nothing. And the partial of y with respect to v is going to be 3. And I want the determinant. Yeah, I'm going to cheat on this one. And if we go down here, we're going to get 3/2 minus 0. So there's my Jacobian right there, 3/2. And now I can just put it all together. So my new integral for my volume would be my double integral, ready, y, which is 3v, my Jacobian, which is 3/2, dA. Now remember, I'm going to go v and then u, so dv du. And now my change in v, we said, was this negative square root of 4 minus u squared to positive square root of 4 minus u squared. And my u goes from -2 to 2. And there's our integral to solve for that volume. So let's take a look at the question from the very beginning. Remember, we had to find out this volume right here using these two integrals, but notice that's pretty nasty. So on our next example, we're going to solve it, and since we already know the equations from above here, up top here, we already have the equations of the lines, we're going to do our transformations for our new base. So the base is, we're going to do the new transformations. Our first line was this y equals x. And they tell me the transformation, what y is equal to and what x is equal to. So if I solve this, we're going to get 2u minus 3v equals 2u minus 3v. And the u's cancel, and we just get v equals 0 right away. Remember, this is a slanted line, and this is a horizontal line. That's going to be much nicer for us right there. The next one, y equals -x. So that becomes 2u minus 3v equals -x. So -x, so it's -2u minus 3v. Here the v's cancel, and we get u equals 0. Again, now that's a horizontal line, already starting to look a lot nicer for us. We did have a couple of other lines here. We had y equals -x plus 5. And I'm going to kind of shortcut this up a little bit. What you wind up with here is u equals 5 over 4. You know, I'm going to give that for you right there. And here we have, the last one was y equals x minus 5. And again, remember, we got those from up here. And if you were to solve this one, plugging these in, you would get v equals 5 over 6. Right there. You can verify that. So my new base, remember my old base was this parallelogram. Our new base, let's take a look down here. If I were to graph this, remember there's u, there's v. So v goes from 0 to, looks like 5 over 6. And then u goes from 0 to 5 over 4. So there's my new region. And if I want to find the limits on this one, I'm going to draw a vertical rectangle right down here, right down there real quickly. My vertical rectangle talks about my change in v. Well, v goes from 0 to 5 over 6, and my u goes from 0, and this is going to move right and left to 5 over 4. Right there. So already, look at this. That's already a much nicer base than that original parallelogram right there. And notice, even better, I only need one integral. All right, but I'm not done yet. Remember, I got to find the volume here. So we still have to, let's see here. We still have to change our function. So we still need to change the function f of x, y. So we have x plus y. What's that going to equal? Oh, that's easy. That's just 2u plus 3v plus 2u minus 3v. So that's just equal to 4u. Oh, wow, that's really nice. That's our new inside. That's our new function. That's our new f of x, y. That's uv right there. That's our function. And now we want our Jacobian. the Jacobian determinant. Sometimes, again, we'll call it just v j sub f. So we need the partial of x with respect to u, the partial of x with respect to v, the partial of y with respect to u, and the partial of y with respect to v. So let's see here. The partial of x, there it is, with respect to u is 2. The partial of x with respect to v is 3. The partial of y with respect to u is 2. And the partial of y with respect to v is negative 3. And I'm not going to cheat on my determinant this time. 2, 2, 3, negative 3. And that's going to give us negative 6 minus 6, or negative 12. So when I want to find my volume now, my new equation, my volume would be my double integral, my function for u times my Jacobian, which is this absolute value of negative 12, dv du. Well, v goes from 0 to 5 over 6, and u goes from 0 to 5 over 4. And I can simplify this a little bit. That becomes 12 times 4, and that's a constant. So that's just, whoops, sorry about that. And that's just 48. So I can write this as 48, 0 to 5 over 4, 0 to 5 over 6, u dv du. Okay, this was a little bit of work, but honestly, the more practice you get, the faster this becomes. But just look at this integral and compare it with the original. Where this was not easy to solve by hand, this one is so easy. I'll let you do it. Alright, anyways, come back to video number 3. We'll take a look at a couple more examples. Let's see you then. Bye-bye.